Welcome back, everyone. This is Mr. Wakefield, and what we're looking at today is what we call rational expressions. Rational expressions are just kind of a fancy way of saying a fraction, but not just any fraction, a fraction that has both a polynomial in both the top and the bottom, the numerator and the denominator of the fraction. Okay. So when it says down here to simplify rational expressions, that's just another way of saying that we are going to put them in lowest terms. Okay, we're going to put these fractions in lowest terms. Okay, you've probably heard that expression before. But what I am concerned about especially here is when you have more than one term on either the top or the bottom. In this case, there's more than one term on both. Unlike this problem, the kind of problem we've seen before, but when you got more than one term, okay, you can't just start canceling things. Very, very important that there's something that you got to do first, and you have to do that thing first. We'll get to that in a minute. Right now, let's review how to put a fraction in lowest terms when you have just a single term in both the top and the bottom. The way you do that is the same way, and we saw this in a different video. When you have a single term on the top and bottom, it's just the same thing as simplifying, okay, which is why one of the reasons why you use the word again here, simplify, in this worksheet as well. Let's review what we did. You divide the coefficients by the largest number that will divide into both of them. Okay, we divided both of these by 4. We got -9/1, okay? And then you subtract the exponents if the variables are the same. Okay, 12 minus 1 gives you x11. 7 minus 4, I know it's not that easy to see that, but this is y7 down here, and this is y4. So we said 7 minus 4 is y3. So let's do that again here, just to kind of get us off to a good start here. When we have, again, a single term on the top and bottom, we take the two coefficients, and if there is a number other than 1, if 1 is the largest number that divides into both coefficients, then don't even bother doing it, because when you divide by 1, it's just going to stay the same. But here, 3 does divide into both of these, and that's the largest number that would do so. And so therefore 9 divided by 3 is 3, and 3 divided by 3 is 1. Okay, so far so good. And then, as I just mentioned in that other problem, since x and x are the same, we take the exponents and subtract them, bigger minus smaller. 3 minus 1 is 2, and so let me remind you again here, when you do that, you put the you put the answer, which is x to the second power, wherever the larger exponent was located originally. So I'm going to put x to the second up here, okay, and I'm going to put 1 wherever the smaller exponent was. It's the same thing here, okay, we got 5 and 1, but this time the larger one's on the bottom. We still say larger minus smaller, so 5 minus 1 is y to the 4th. These cancel. We put the y to the 4th wherever the larger exponent originally was, so we put it down there. And we put a 1 wherever the smaller exponent originally was, in this case the top. We then multiply the different parts together, again, just like we did in that example I just showed you. 3 times x squared times 1 is 3x squared. And 1 times 1 is 1. 1 times y to the 4th is y to the 4th. And so putting a fraction in lowest terms, when you have a single term on the top and bottom, that's all you got to do. Okay, do the coefficients, do the variables if the variables are the same, subtract the exponents, all that stuff. Now here's the thing, you guys. When you have more than one term on either the top or the bottom, or in this case both the top, you see how both the top and bottom have 3 terms here? It is absolutely mandatory. Don't even think about canceling yet. Okay, look up here. It says in the directions here, simplify rational expressions. Okay, now this first step is not necessary if the top and the bottom are single terms like we saw in the problem we just did. Okay, you don't need to do this step if it's just a single term on the top and bottom. But if there is more than one term, in the top or the bottom, you need to do this step right here. Okay, you got to factor the numerator and denominator completely. And so we're going to do the factoring. Little review right here about factoring. Again, we're always going to look for the GCF first when we're factoring. You'll notice in both of these polynomials, though, the GCF is equal to 1. Okay, and so you can skip that step when that happens. But then in the second step of the factoring process, if you have 3 terms and it's in this form where you have x to the second and then x to the first and then no x at all, okay, we do the Berry method. Okay, so how's the Berry method work once again here? All right, we're going to say 1 times -5 is -5. And then we list out pairs of factors for -5 until we find a pair that equals -4 when we add them. Okay, well, 1 and -5 will work. Okay, so we found it right away right there. And that means that we do what? That means we're going to do x and x. We're going to do x and x because this is 1x squared, and so you do 1x and 1x. Okay, if this had been 2x squared, you do 2x and 2x. But because it's 1x squared, we have 1x and 1x. And then we put in +1 and -5 because that's what these two numbers tell us to do. Then we also know that when you get 2 brackets, sometimes one of those 2 brackets factors further. However, and when that happens, typically it's through the a squared minus b squared formula. Okay, where you got to have something squared minus something squared. But whenever you have a variable to the first power, that's never going to fit into this. That's never going to fit into this. And a lot of your brackets are going to have a variable to the first power. Whenever you see that in one of these brackets that has 2 terms in it, that automatically tells you that that bracket is not going to break down to 2 more brackets. Okay, like we saw in a different video where sometimes you get your 2 brackets and one of them breaks down to 2 more here. Okay, here's an example of it. But that does not happen here because x is to the first power. Same thing with this one. Okay, we'll never fit into that. So this is done. This is factored completely. This is not one of those problems where you end up with 3 brackets. Okay, just like it happens most of the time when you factor, you usually will end up with 2 brackets. This is one of those cases. Same thing here. In this problem here, you go 1 times 4 is 4, and we need to find 2 factors that add up to 5, a pair of factors for 4. Well, 1 and 4 would work, wouldn't they? Okay, they would add up to 5, and they equal 4 when you multiply them. That's a pair of factors for 4. They multiply together to equal 4. And so once again, because this is 1x squared, we're going to say 1x and 1x. And then since these are both positive, we're going to say +1 plus 4. Okay, now we factored completely, right? Okay. What it says here next up here, I'll come back down to the problem in a minute. It says identify the factors of the numerator and the factors of the denominator. Okay. I'm going to use different colors here. You don't have to do that on your paper, but just to help you understand, okay. Factors are things that are multiplied together. So if you just end up with 2 brackets in your numerator or denominator, that's going to equal 2 factors. Okay, and it's going to be those 2 brackets there. I'm putting it in red, the color red, because when we get a single term factor, that's going to be treated completely differently. And so therefore I'll put that in a different color just to make it easier to keep track. Okay, but the point is that these are our 2 factors because those 2 things are multiplied together to equal the entire numerator. Whenever you get just 2 brackets after you factor, no GCF in front, not one of those problems where you have 3 brackets. No. Just 2 brackets, then it's going to be 2 red ones here. Okay, I'll get into the color stuff more and more as we go along here. Same thing down here. If you got just 2 brackets, that's just 2 red ones right there. Now, here's the thing, you guys. The way we cancel with single terms is different. We'll get to that here in a little bit as we see it. Okay, but when you have these factors that have more than 1 term in it, and that's going to be the red ones. The red ones have more than 1 term in it. Okay, you're only allowed to cancel one of these red factors that has more than 1 term in it if they are exactly the same. In other words, I can't cancel the x plus 1 and x plus 4. You might be thinking, hey, can I cancel the x and the x right here? Okay, no, you can't. You can never cancel part of a red factor. In other words, you can't cancel the x and the x and then leave the 1 and the 4 there. Okay, you either cancel all of a red one or none. You don't cancel the red one at all. You can't cancel part of it. Okay, so you are allowed, however, to cancel two red ones if they are exactly the same, and you have to cancel the whole thing. Okay, so what you do is you go like this, cancel the whole thing. Now, since they are the same, let me just give you a little bit of an example here. It's kind of similar to when you have single terms and you have, for example, two numbers that are the same. If I cancel those, I divide them both by 8. And so you get 1 over 1. This is a different example, but I'm showing you this because when when you cancel two things on the top and bottom that are the same, you should get 1 over 1. And so in the same way, when you cancel two red factors, they are both going to be equal to 1 over 1 as well. And so that's why those are allowed to be factored. Or I'm sorry, those are allowed to be canceled. Can I cancel any stuff over here? Okay, no, I cannot, and the reason why is because, again, you can't cancel the x's because you're not allowed to cancel part of a multiple term factor, which is what these red things are. They're multiple term factors. They're factors that have more than one term in them. Both of these red things have two terms in them, so you can't cancel one part of it. Okay, you can't just leave the -5 and the -4 there with the x's canceled out. Okay, so the only way you can cancel these is if they're both exactly the same. There is one exception to that, which I'll show you in a minute, but otherwise, you can only cancel these red ones if they're completely the same like these two were, and you cancel the whole thing. Now, I'm going to just get this out of the way here just to make room to write down the answer. Okay, I'll move it over here a little bit. There we go. But the answer here is going to be 1 times x minus 5. And whenever you multiply a bracket times +1, you don't need to keep the bracket anymore. It's okay to keep it. It's not wrong to do that. You could still keep the bracket around the x minus 5. You just don't have to. If you multiply a bracket times anything else, that's different. You can't just get rid of the bracket there. Okay, unless you actually distribute out the number it's being multiplied by. But if it is being multiplied by 1, you can just say the inside of the bracket. Because if I were to distribute the 1 here through both of these terms, it would be equal to this. Okay, it's just the same thing without the bracket. And so that's what you do there. You factor, and then if you have red factors, you're allowed to cancel if they are exactly the same. Okay, let's try that again. This one's going to look a little bit different, though. That's one of the reasons why we're doing it. Okay, so in both the top and bottom here, once again, we have more than one term. More than one term. That means we don't start canceling. We're not allowed to cancel x3 and x3. I know that's tempting to do that because they're the same. But you're not allowed to do that because of the plus and the minus. The plus and the minus makes this 2 terms on top, and it makes these 2 terms on the bottom. It's not like this problem over here where you can start canceling right away because you don't have the plus and the minus. Okay, you just have a single term on the top and bottom. Okay, so we have to factor these things just like we did in problem B. Now, in both of these, we have a GCF. The GCF on top is going to be 4x squared. In other words, the GCF is not going to be equal to 1. What's on the inside there? Well, 4x squared times what is equal to 4x to the third? It's going to be equal to 1x. And 4x squared times what is going to be equal to positive 8x squared. Wouldn't that be positive 2? Which means I got to put a plus right there. Okay. Now, we have to factor it completely. That means that after you factor out the GCF, you have to try to factor this bracket down into 2 brackets. Okay. However, as I just mentioned, when you are actually, there's a little bit more to it than that, but I'll say that right now. When you have the GCF, you factor it out and you have 2 terms, okay, and you just got the 1 bracket, all right, as was discussed in a different video, when you have 2 terms, at least for now, the only thing you have to consider is this. If this doesn't work, then you can say that this is done. You don't need to break it down to 2 brackets. Okay? And like I mentioned a minute ago, when you have a variable to the first power here, it will never fit into that. Never. Okay? You can't have something taken to the second power equal to x to the first. The exponent's too small. Okay, 2 wouldn't work either. We don't have something to the second power equal to 2. If this had been a 4, that might work, as long as that's a minus. Okay, the plus actually prevents it from working as well. So there's a lot of reasons here why this doesn't work, but it doesn't work. And this is the only formula we use when we try to factor 2 terms right now. And so this is done right here. So we're done factoring the top. Now what I'm going to do is when you have a GCF times a just a single bracket, I'm going to call the GCF, because it's a single term, I'm going to make that a green factor right there. Okay, that's green there. It's hard to notice that on the video. Okay, whereas the bracket that has more than one term in it, that's red. Okay, again, I'm doing that because the way we treat single term factors is going to be different. So I'm just trying to make it easier with colors to notice that. Okay, we'll get into that more here in a second about how to do the single term canceling. Okay, so then on the bottom, the GCF there is going to be x. And then if you factor that out, we get what? We get x squared minus 4. But this time, x squared minus 4, since it's got 2 terms, and once again, we have to consider that formula, okay, as was discussed in a different video, like I said. And that formula does fit into this, okay, because x squared minus 4 is the same thing as x being squared and 2 being squared. And so the formula tells us to do what? Okay, it tells us, in fact, we have a similar problem here that I just showed you a little bit ago. When you have x squared minus 4, it's going to be, because it's x squared minus 2 squared, it's going to be x minus 2, x plus 2. So let's write that down. Okay, so we're not done factoring the bottom yet, so we'll get back to dealing with the top of the fraction in just a moment. So the x squared minus 4 becomes x minus 2 and x plus 2. Remember, when you factor out a GCF out of the original polynomial, in this case the original denominator, you've got to keep that x there. It's still there. But then this bracket broke down to 2 brackets. Now, as I mentioned, when you have a single term factor, that's going to be green. Now let me go over this. When you have a GCF times 2 brackets, that's going to be a green one and 2 red ones. A green one and 2 red ones. Green because that's single term and it's being multiplied by these 2 red ones here. Okay. Whereas when you have, again, when you have a GCF times just 1 bracket, that's a green and then just 1 red. Okay. So these are the different scenarios you're going to see when you factor. If you've got just 2 brackets, it's 2 red ones. If you've got a GCF and a bracket, that's a green and a red because that's the single term. When you have a single term and 2 brackets, it's a green and 2 reds because, again, the single term is going to be green. And then the brackets that have more than 1 term in it, that's going to be red. Okay, now, the way you cancel single terms is different. Okay, they don't need to be exactly the same like the red ones did. Okay, with the green ones, you cancel them the same way that you canceled these. Okay, but they both have to be green, you guys. Okay, you can't cancel a green one with a red one. You can't say 4x squared, I'm going to cancel with this x right here in the red bracket. No, you can't do that. Okay, when you cancel, you can only do green with green, and you can only do red with red. Okay, so I'm going to cancel 4x squared with x the same way I canceled this over here. Okay, where I start out with the coefficients, 4 and 1. I can't cancel anything with 4 and 1, though, can I? Okay, because the biggest thing you could divide into 4 and 1 would be 1. And when you divide by 1, it's not going to change anything. However, you can do the x squared and the x. Okay, the exponents are 2 and 1. And so we say 2 minus 1. And then we, what? We then take that answer, which is x to the first, and we put it wherever the bigger exponent originally was. And then we put a 1 where the smaller exponent originally was down here. Okay, so we end up with 4 times x over 1, okay, for the single term part of the problem. Okay, I'll get down to writing that as part of the answer here in just a moment. I'll write down the final answer up here. But what did we say about red factors, you guys? You can only cancel them if they are what? Exactly the same. Be careful here, you guys. I know that these two look almost the same, but because of the plus and the minus, they are not exactly the same. And so therefore, these two are the ones you want to cancel here. And when they are exactly the same, you cancel the whole thing, talking about red ones here. And then just like in this problem over here, it becomes a 1 and a 1. Okay, so red ones, again, if they're exactly the same, you can cancel them. Let's organize everything here now. We have 4 times x times 1 now. 4 times x times 1 is 4x. So the entire numerator just becomes that little thing when we multiply everything back together. Down here we have 1 times this bracket times 1. Now when you multiply by 1s, okay, it doesn't change it at all. So you got this bracket in the middle being multiplied by a couple of 1s right there. And so it's just going to be x minus 2. And you don't need to keep the bracket, like I said in the last problem, when you multiply by 1s. Okay. And so there you go. We are done with the canceling. Okay. And so therefore that's what you get. Don't cancel the 4 and the 2. Don't cancel the x's, okay? If those things were able to be canceled, they would have been canceled down here somewhere. Okay, so as long as you did all the canceling you possibly could down here, okay, this should be the right answer. Okay. And so that's why that's the final answer right there. Okay. So do all the canceling you can with the greens. Do all the canceling you can with the reds. Okay, notice that after you cancel these 2 red ones, the x minus 2, there's not another red one other than 1s to cancel. Okay, and the 1s are not going to cancel with anything. Okay, they never do. Okay, 1s never cancel with anything. So that's C. Problem D. Now notice in problem D that we do have a 2 terms on the top right there. However, this is prime on the top. How do I know that? It's because the GCF is 1, okay, and you can't break that down to 2 brackets. And the reason why I know that is because that's got 2 terms. That's got 2 terms right there, and it doesn't work for this formula, which is what we use for 2 terms, because like we said, when you have x to the first power, it doesn't work for this. And so that means that this thing is prime, which means it doesn't have I mentioned in a different video that prime means that the GCF is 1 and you can't break it down to 2 brackets. Okay, so what do you do in that case? What you do, it doesn't mean that the problem can't be done. It means that what you have right there, if it has more than 1 term in it, okay, it's just 1 single red one. I know it doesn't have a bracket around it, but it doesn't need to, because remember, officially red ones are multiple term factors. Because it didn't break down to 2 brackets like it did up here, okay, it's just 1 red one. It doesn't break down to 2 red ones like it did here. So a prime polynomial with more than 1 term, that's just a single red one, because you weren't able to break it down to 2 red ones. Okay, unlike this bottom part here, where we have, again, the GCF is 1, but doing the Berry method because of how it's set up right there, just like these problems up here in problem B, we go 1 times -3 is -3, and then what adds up to -2, you guys, out of the factors of -3 is going to be 1 and -3. And so that's going to be x plus 1 and x minus 3. And those brackets, you can't factor those any further, okay, because it has x to the first power. Okay, so it's not going to work when you try to do the a squared minus b squared formula again. So that's done factoring, okay, you can't factor those any further. Those are 2 red ones, just like these were when you have just 2 brackets in your top or bottom of your fraction. Okay, so that's what we got. Okay, now there's no green ones this time, you guys, unlike the last problem. So you can ignore the green canceling, okay, like we had over here. Let me zoom out a little bit for you. There we go. You can ignore the green canceling because there is no green this time. But the red ones, what can we cancel here? We can cancel these two because they are exactly the same, right? Okay, and so you're allowed to do that, like we've seen here in a couple of these problems already. And so we get 1 over 1 again. And then x minus 3 doesn't have anything to cancel with it, right? So we just leave that alone. So on the top, all we have is a 1. On the bottom, we have 1 times this bracket. And as we already said, when you have 1 times a bracket, you could keep the bracket if you want, but you can just say the inside of the bracket there. And we did it. We put it in the lowest terms. But again, it's so important to not start canceling until you factor, unless it's one of these problems where it's a single term on the top and bottom. Then you don't have to factor. Okay, now I mentioned a few minutes ago about how you can only cancel the red ones if they're exactly the same. There is one exception to that. You'll see it in this problem right here and in a few other ones that we're going to do. Okay, but listen out closely for that. But other than that, they have to be exactly the same. So let's see what happens. 5x minus 2 once again is going to be prime just like x plus 1 was, because its GCF is equal to 1 and it has x to the first power, so it's not going to work for the a squared minus b squared formula. And so once again, when you have a prime polynomial, that's going to be a single red one since it's got more than one term in it. Okay. Then on the bottom here, okay, this has a GCF of 1, but notice that this fits into the a squared minus b squared formula because 4 is 2 squared and 25x squared is 5x to the first squared. Okay, and so therefore, I can use this formula here, okay, to do that. And again, the 2 would go here and the 5x would go here. And so 2 squared minus 5x squared would be what? It would be, according to that formula, okay, I'm just bringing it in from a different sheet here. So let's say it again. 2 squared minus 5x squared would be 2 and 2 go here. 2 and 2, okay, because that's the a, and then minus 5x and plus 5x. All right, and so we're going to get 2 minus 5x and 2 plus 5x. Now, notice that that's a couple of brackets there. It's a couple of brackets. And so we have one bracket or one red one on top and 2 red ones on the bottom. Now, notice that none of these 3 are exactly the same. But like I said, there's an exception. Notice in these 2, just look at these 2 right here. Don't look at this one over here. Just look at these 2. Notice that you have 5x and negative 5x. Positive and negative. They're the same, but they're the different sign, right? Positive 5x, negative 5x. Same thing here with negative 2 and positive 2. They're both 2, but one of them's negative, one of them's positive. Okay? What you can do as an exception to this, it's the only other exception, is that if they're not the same, but both of the terms are the same still, but they're different sign, they both have to be opposite sign. Positive 5x, negative 5x, and negative 2, positive 2, okay, is you can cancel those. Okay, but you cannot do this one because even though the 2 is an opposite sign, the 5x is not. Both terms have to be opposite sign. So they either have to be exactly the same like up here, where they're both the same sign, positive x, and positive 1, or they both have to be opposite sign, 5x, negative 2, positive 2. So they either have to both be the same sign, or they both have to be the opposite sign. If they are both the opposite sign, then what you do is you don't say 1 over 1. You say negative 1 over 1. Okay? So if they're both the same sign, you say 1 over 1. If they're both the opposite sign, you say negative 1 over 1. Okay? And those are the only 2 times you can cancel red ones. Okay? That's the only time. So that's why you can't cancel these 2 right here. It's because only one of the two terms was opposite sign. The 5x was the same sign, the 2's were not. Okay? So we're done with our canceling here. We get -1 on the top here. And we get 1 times a bracket again, which again just means the inside of the bracket. And there we go. Okay? All right, so that's how you do red ones, okay? There's 2 different times when you can cancel. Okay, they're both exactly the same, or they have that same term but opposite sign on both terms. They got that thing going on. Okay, that's when it's -1/1. Here we have a GCF. It's equal to 1y. If I factor it out, it's equal to y plus 1. Y squared, I'm just checking my answer, y squared plus y. Okay, make sure your GCF is correct as well. Okay, and then, so that's going to be what? As we learned up here in problem C, okay, when you have a GCF times a bracket, that's just going to be a green and a red. And y plus 1 cannot be factored, partly because you have y to the first and it's 2 terms. Automatically, that doesn't factor like we talked about. Now, when you have a term times a bracket, see how this looks the same on the bottom here where you have a term times a bracket? When it's already set up like that, okay, if you already have a term on the outside and then at least 1 bracket, okay, what you do is you just check to make sure the bracket cannot be factored into 2 brackets. And it can't be because it's got 2 terms and it has y to the first power. So this has actually already been factored for you. Usually you got to do the factoring as you can see here in these other problems. But this time, no. Okay. This time they already did it for you. But check that bracket just to make sure it doesn't break down to more brackets. Okay. Now, again, just like in problem C up here, when you have a couple of green ones, one on top, one on the bottom, you're allowed to cancel those if it's possible. Just a reminder here, you guys, when you cancel, if the y and the y are the same exponent, y to the first and y to the first, you don't have to subtract. What you do is you just cancel them completely. They become 1/1, which makes sense because they're exactly the same, just like the 8 and the 8 were exactly the same and it's 1/1. Just like the brackets are exactly the same, they become 1/1. Okay, the y and the y are exactly the same as well. Okay, and there's no coefficients to cancel there either. So that's it for the green. Again, you have to cancel green with green. You never cancel green with part of a red one. So we're done with the greens there because they're just ones now. Okay, can I cancel the green? I'm sorry. Can I cancel the red ones? Can I cancel the red ones? No, I cannot because you're not allowed to cancel the y's. You can't cancel part of a red one and then leave the rest of it there. Okay, so we just end up with 1 times y plus 1 and 1 times y plus 10. And there we go. Okay. So that, you guys, is basically what putting fractions in lowest terms is about, even when you have more than 1 term on the top and bottom. Okay. Now, the good news is that as we go on into these last 3 problems, is that when you multiply and divide fractions, it's almost the same exact thing, believe it or not. Okay, even though the problems look bigger and everything. Okay, when you multiply and divide, the rule is still the same where, because what we're going to do, let me back up a little bit. When you multiply, and it's going to be similar for division, when you multiply, you are going to be doing a lot of canceling as well. Okay, you don't want to just try to multiply these things together now, okay? You want to try to cancel everything first to make everything smaller. Then it's easier to multiply stuff. So we cancel before we multiply. I'll introduce the directions up here. Notice the steps here for the first 3 steps are exactly the same steps as they are for simplifying, which is when we put it in lowest terms. Exactly the same steps. So we're going to do all the same things. It's just that we're not going to multiply till the end. Okay? So let's get to it here. When you multiply fractions, assuming you don't have single terms in all 4 of these spots here, which we don't, Okay, in that case, you wouldn't have to factor, just like in this problem up here, we didn't have to factor the single terms. We factor everything because there's more than one term in all of these except for this one. Remember, you don't have to factor a single term, so we can just leave this one alone until the end when we multiply stuff. But the other three we have to factor or try to factor. Okay, so in x squared minus 25, that's going to be x squared minus 5 squared. It does fit into the a squared minus b squared formula. Sorry about that. There it is. And so that's going to be x minus 5 and x plus 5. Okay. And so that's going to be what? That's going to be 2 red ones right there. Okay. Underneath that, that's the Berry method right there. 1 times negative 10 is negative 10. And we have to find a pair of factors for negative 10 that adds up to negative 3. These pairs do not work. However, this one, if you keep on going, you eventually find one here, right? Okay. Unless it's prime, but this one is not. So 2 and negative 5 add up to negative 3. So it's going to be x plus 2 and x minus 5. Don't cancel yet, all right? We still got to do the other fraction here. Okay. So this is just, again, going to be 2 red ones. Now notice that x plus 2 is prime. It's prime because its GCF is 1. And it's got x to the first power along with the fact that it's got 2 terms. 2 terms with x to the first power automatically means you can't break it down to 2 brackets, unlike x squared minus 25 where we were able to break it down with the 2 terms because it had something squared minus something squared. Okay, so x plus 2, as we said before, when it's a prime polynomial, it's just a single red one because it's got more than one term. X, as we said also, you don't have to factor a single term, but what happens if we're identifying our factors here? If you have a single term denominator, same thing if it had been a single term numerator up here, we're just going to underline it in green because it's single term. So if you have just a single term numerator or denominator, that's just a single green one. Okay, and that's important because remember, you cannot cancel a green one with a red one, even part of it. So you do not cancel this thing with anything up here because there's no green. Okay, when you cancel with fractions, you guys, you have to cancel something on the bottom with something on the top. Okay, but you're not allowed to cancel green with red. Okay, so we need to leave this alone. Don't touch that. Okay, so we can't do anything with the green one. Okay, now let me remind you here, you can what? You can cross cancel, meaning you can cancel x plus 2 with x plus 2, even though they're not in the same fraction. As long as you have one on top, one on the bottom, you can cross cancel, but only when you're multiplying. Let me say that one more time. You can only cross cancel when you are multiplying fractions. You can't do it when you're dividing unless you first of all convert it to a multiplication problem, which we'll learn how to do. But if there had been a plus or minus here, if we were adding or subtracting these fractions, you can't cross cancel. Only when you're multiplying. But because we are multiplying and because these two things are exactly the same, which is an example of something that's allowed to be canceled, 2 red ones that are the same, we're going to cancel the same way we did before, where you make it 1 and 1. Okay? And now nothing else. Oh, I'm sorry. There is one more thing we can cancel. Even though you can cross cancel, you're still allowed to cancel within the same fraction too. That's still allowed when you multiply fractions. And so these two are exactly the same, and so I can cancel those as well. Okay. Now I'm going to just clean up my mess right here, all right? You don't have to do this. You can do this in your head if you want. But just to make sure I know what I have before I actually do the multiplication process, I have 1 times x plus 5 in the top of the first fraction. 1 times 1 underneath that is 1. I'm going to go ahead and write down that 1. I know I don't always have to write down a denominator of 1, but I'm going to write it because when we multiply fractions, we want to have denominators, you guys, even if they're equal to 1. You'll see why here in a second. And then here we have 1 over x. Okay, the reason why you want to have denominators is because it is now time, now that I've done all the canceling I possibly can. Do not multiply until you've done all the canceling you possibly can. And make sure you know what you have. Okay, that's why I wrote down this extra step, to clean up all the stuff that got canceled out. Okay. And now I'm ready to multiply. Multiply means to multiply the top parts together and the bottom parts too. That's why you want to have bottom parts down here, even if they're equal to 1. So x plus 5 times 1, anything times 1 is itself. Okay, so it's just x plus 5. And then 1 times x is x. Okay, and we're done. Now, again, you might be thinking, hey, can I cancel those x's? No, you cannot. Okay, if something was able to be canceled, it would have been able to be canceled up here. So since we did all the canceling we possibly could up here, okay, there should be no more canceling that takes place. Okay, so those x's, that's why those x's do not cancel. Let's do that again here. Okay, what do we have here? We have some GCF. We have a GCF on this one. Okay, we have 2, and then factoring out the 2, we get 3y plus 1. Just checking my answer. 2 times 3y, 2 times 1, it's equal to those two terms right there. Okay, so we get green and red. Okay, underneath that, don't we have y? I'll just write it down here. We have y squared minus 1 squared. Okay, that's what this is. Okay, and so that's going to be what? That's going to be y minus 1 and y plus 1. And that's a couple of red ones right there. 1 minus y right here, that's prime. It's prime because the GCF is 1. And it has y to the first power, which means that since it's 2 terms, you can't use the a squared minus b squared formula like we did on this one. So that's just a single red one. And then this has a GCF. Okay, the GCF is equal to y. And then when we factor that out, we get 3y plus 1, same as that one up there. By the way, 3y plus 1 does not factor because, again, it has 2 terms with y to the first power. So that cannot break down into 2 brackets like we already talked about. And so that's a green one and a red one there. Now, what we do, let me separate that right there. What we do now is, again, remember, you're allowed to cross-cancel. So I can at least try to cancel the 2 and the y since they're both green. But nothing cancels with 2 and y, does it? Okay, in order to cancel y, you got to have a y up here in this green one. Again, you can't pick a y from one of the red ones. That's not allowed. You can't cancel green with red. But just looking at the 2 and the y, okay, there's only a y in one of those 2 places, so you can't cancel the y. And then the 2, and there's an invisible 1 right here, but you can't ever cancel with 1. And so the 2 and the y, we tried to cancel, as you're supposed to when you have a green on the top and a green on the bottom. But it didn't work here. Okay? And so now we try to cancel the red ones. Notice that we can cancel these 2, and you are allowed to cross-cancel because we're multiplying. Since they are exactly the same, we get 1 and 1. Notice also I can cancel these 2 right here. I can cancel those 2 because they have that same term opposite sign thing going on. Positive y, negative y. Positive 1, negative 1. Okay? So I can cancel those, but don't write down 1 and 1. We're going to write down negative 1 and 1. Just like I did up here, negative 1 and 1. Negative 1 and 1. Now let me clean up my mess here. I've done all the canceling I possibly can. Y plus 1, there's nothing to cancel from up here with that. Okay? So we have what? On the top here, we have 2 times 1. Underneath that, I have 1 times y plus 1. Here I have negative 1 on the top. And then here I have y times 1 is y. Now here we got to be careful. Put my answer down here. Okay, Now we're ready to multiply because we've done all the canceling we can. We've cleaned up our mess. Okay. We got rid of all the cancelings and stuff. All right. When you multiply two denominators together, okay, same thing if it had been two numerators. If one of them has more than one term in it and you're not multiplying by 1 like we did over here, when you multiply by 1, that's different. Then it's just, you can just write down the x plus 5. But even though that has two terms, okay? But if you have something with two terms in it and you're multiplying it by another denominator that is not equal to 1, you have to bracket that. Because if you don't do that, if you just write down this right here, if you just go like this is not good. Because it looks like you're just doing y times y instead of doing y times this whole thing. So don't do this. Okay, you got to bracket that. Now you might be wondering, can I put the y behind the bracket? You can. Okay, remember you're multiplying, so it doesn't matter what order you put the y and the y plus 1 in. As long as they're being multiplied, the order doesn't matter. And we usually put a single term in front of a bracket when we multiply. It's just how we usually write it in math. And so that's why I did that. But you could have put the y over here instead of putting it in front as well. That's okay. It's just not how it's usually done. But again, if you have two terms and you're multiplying it by something that's not equal to 1, you got to bracket it. Okay, got to bracket the thing with two terms. Okay. Now you might be wondering, can you distribute this out? Yeah, you could distribute that out as well. You don't have to, though. Okay. We're not concerned about distributing it out right now. We're just concerned about doing all the canceling we can. And then we say that this is being multiplied together by bringing it together and saying it's being multiplied. You don't literally have to distribute it out. Okay. So yes, if you do distribute that out, that's also okay. Anyway. Last one here. This is a division problem, you guys. Division is exactly the same as multiplication except for one big thing which you must do first. You must take the first fraction and keep it the same. But then you take the second fraction and first of all, even before that, you change the division symbol to a multiplication symbol. That's what's going to allow you to be able to cross cancel. Okay, you got to convert it to a multiplication problem in order to cross cancel. Then you flip the second fraction. It's called the reciprocal. Maybe you remember that word from the past. Okay. So dividing two fractions means the first fraction stays the same. The second fraction flips. And then the middle becomes multiplication. Okay. Now, even though 7 and 28 are single terms, because these are not right here, you got to go through the factoring process. Now the 7 and the 28, because they're single terms, you keep them the way they are, just like the x in this problem over here. It's just going to be a single green one, okay? But we have to at least try to factor the y minus 5 and the 3y minus 15, okay? So y minus 5, that's prime, okay? It's got a GCF of 1. It's got y to the first. It's prime. Okay. 3y minus 15, that's got a GCF of 3. And then y minus 5. So this one is going to be a green one and a red one. Okay, now I've done all the factoring that I possibly can. Now it's time to try to cancel. Okay, notice I have 3 green ones this time. That's kind of rare, but it happens sometimes. When you have that, what you got to do is you got to try to match up one with the top and one with the bottom. And you keep on doing that until nothing cancels anymore. Notice that the 3 and the 28, they do not cancel. The only thing you could divide into both of those is 1, and that's not going to change it. So it doesn't cancel. But 7 and 28 do. 7 and 28, you can divide both of those by 7 to equal 1 and 4. Now, what do I got left? I have 1, 3, and 4. 1 and 4 are still eligible to still be canceled even further if that's possible. Okay, when you have more than 2 green ones, that is possible that something could be canceled more than once. Okay, if you have just 1 green one on top and 1 green one on the bottom, like we saw up here, if you do it right the first time, you shouldn't have to cancel again. But when you have more, and this is rare, but when you have more than 2 green ones, you got to double check to make sure the 1 and the 4 doesn't cancel again. Like for example, can the 4 be canceled with the 3, you guys? No. Okay, but you got to at least try that. So 1, 3, and 4, nothing cancels there. Okay, so we're done with the green ones now. However, I can cancel the y minus 5s because they're exactly the same and they're both red, and they become 1 and 1. Let's clean up our mess here. We got 1 over 1. That's all we got on the first fraction. Bring down the multiplication symbol. We have 3 times 1, which is 3 over 4. Wow, this really cleaned up, didn't it? There's no variables left or anything. That doesn't happen very often, but sometimes it does. So this is really easy to multiply together. It's just a bunch of single numbers here. 1 times 3 and 1 times 4. Okay, so remember, you got to do that first. You got to flip it first. Okay, I see a lot of students, they will start canceling or start factoring first. They'll forget to flip it, and then you end up canceling the wrong thing because the fraction didn't get flipped like it was supposed to. So make sure to flip that fraction first, then do everything else, and then you'll be able to cancel the correct things. Okay, so that concludes our worksheet on rational expresses, in particular, putting them in lowest terms like we did up here, and then also multiplying and dividing them.